When an earthquake strikes, the ground starts shaking in many different ways. The houses that are not sturdy enough may collapse, causing great losses. I am Architect Kiki. Do you know how to build houses at different locations? This is a seismic hazard map. The colors and numbers marked on the map indicates different levels of earthquake resistance required in house building. Wherever it is, houses should be sturdy. Factory building. Do you know where it's safer to build a house? Is it at the foot of a hill? Or is it on flat ground? That's not correct. Houses that are built at the foot of the hills may be buried by landslides when an earthquake strikes. Houses should be built at a safe location. Let's start digging. Now let's fill it with layers of different kinds of materials. We'll still need some concrete to fill the foundation pit. This is a concrete mixer. Let's make some concrete. Add the raw materials first. Stones. Cement. Sand. Pour them all into the mixer. Screw the hose pipe to add some water into the mixer. Let's start mixing the concrete. In the concrete and the foundation will be sturdy. Good job! Select a factory building. Wow, the factory is built! Great job! Buildings with modified foundation and buildings without modified foundation will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Wooden pavilion. Assemble the bucket arch. This is a bucket arch. It is pieced together by 3 wooden parts. The wooden parts are not fixed to one another. Placing the bucket arch between the roof and the columns not only supports and stabilizes the structure of the entire house, but also absorbs some shock waves by deformation during an earthquake, which reduces the risk of collapsing. Pick a roof you like. Apply the cement. Let's put some tiles on the roof. Then paint the columns. Wow! The wooden pavilion is built! So pretty! Buildings with mortise and tenon joints and normal buildings will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Skyscraper. We will need some steel components for building a skyscraper. Lift some up from the ground. Sort out the steel components by their shapes. Tie the steel components into bundles. Lift the steel components up for building the roof of the skyscraper. Slide the lever to the left and right to put the steel components in the right place. steel components with the hammer to align them. Now let's build an enormously big wind damper on the top of the building. Pull the handle to hoist the iron ball. Tighten the screw to fix the iron ball in place. Now install the small damper to connect the iron ball to the foundation. Spin the wrench to fix the screw. The iron ball of the wind damper is very big and heavy. It is as heavy as 132 elephants. Fix it in place on the top of the skyscraper. During a typhoon or an earthquake, it will swing from side to side so that the skyscraper is sturdier and does not shake. Wow, the skyscraper looks so grand! Buildings with shake reduction measures and buildings without shake reduction measures will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going!